Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm continuing to talk about GMV6 heat recovery, the inside components in the outdoor unit. This presentation divided into these 4 parts. Next chapter, we will go to the heat exchanger and pressure vessel. Subcooler located here just after the IPN cooler and the outdoor heat exchanger. Here is the working theory. You can find that this is the plate on the left side and the right side. There are 2 different flows. We just make them to make heat exchange inside. And this is the sectional view. You can find that this one is actually the plate. It is not flat. We make it to be uneven just to higher the heat transfer efficiency. And here is the appearance. Actually, it is a little bit small size. And here is the detail function for cooling, which is to increase the subcooling degree. And how we operate is also you can find it. We just make the refrigerant to divide it into these 2 flows. This is the partial flow, and then we get through this EXV and get expanded. Then become low pressure and temperature. Then it can absorb heat from the main row. Then the output is already itself. It become the gas or vapor. And then it will flow back to the gas liquid separator. And also we can make the main row the temperature to be lower, which to increase the subcooling temperature. This is for cooling. As for the heating, here is also the liquid. Also, we divide it into these 2 parts. Also, the partial refrigerant also will become vapor or gas just through this subcooler, and also from here it will flow to the compressor from this EXV, EVI EXV. And here is a question that you can find it. This is a subcooler solenoid valve. My question is, during heating with EVI, will this on or off? So the question is this one, and the answer is it should be off because it connected here. This is the gas liquid separator, which is the low pressure side. If the refrigerant go to this one, and if this is turned on, it will absolutely get to the gas liquid separator because it is a low pressure, and on the other side it is the middle pressure, so it will always go to the low pressure side. For this heat exchanger, it is the same as the GMV6 heat pump series, so I just copy from that just for your reference. About the heat exchanger, compared with GMV5, GMV6 improve or upgrade lots of the points. First is the partition heat exchanger design. For the GMV5, this is the outdoor heat exchanger. You can find that this is the outdoor distributor, and for this whole outdoor heat exchanger, it is just one. And for GMV6, we divide it into these 2 partitions. And the benefit, just compared with GMV5, it is that this is the distributor when you need to distribute the liquid refrigerant in heating from here to the furthest passes. This is actually the small size tube, and for mass production, it is not that easy to control this lens. And the result it is that if we cannot ensure this lens, we will make the distribution not that even. And not that even also in heating, that means it can be loss of the ice easily on the surface of the outdoor heat exchanger, and which means for the heating which is the performance it will be poor. And for GMV6, also we adopt the distributor to distribute the liquid refrigerant. But as we divide it into two, so from the distributor to the furthest pass, the length is only half of it. So it will make the control in mass production more easier. And the next is from the distributor to the outdoor heat exchanger. For GMV5, the flow is only 1 and it become only 1. And for GMV6, we adopt this from here, it is 1 and then divide into 2. And then here we combine these two together and make it to be 1. So from this design, we can higher the heat transfer efficiency and also amount either from the simulation or from the test results. And next is for the fin features. And for GMV5 is slip fin. You can find on the surface, we just make lots of the slip on the surface. And for GMV6, we just make the flag to be uneven. And from the heat transfer efficiency, definitely GMV5 is higher. However, in heating mode, as the outdoor heat exchanger, there are will generate the condensing water in low temperature situation. It will become ice, which means the ice will stick on the surface of the fin. And if there are lots of the slip here, when we do the defrost, which will make the ice to become water, and the water will not flow out easily because they will just stick on this slip. And then next time when it is going back to heating, this will cool down again and become ice easily, which means for heating performance, slip fin is not that good. And for this corrugated fin, as there is no slip on the surface and the water which is become from the ice can flow out easily, which we can higher the heating performance, especially in low temperature heating, and also make it to be easier defrosting. IPN cooler located here, because we apply the inverter compressor and lots of the heat will generate from the compressor IPN, and we apply the refrigerant to cool it down. So just compare with the air cool, it is max 8 degrees, will be lower. And what we call is subcooling. It is because at this part it is completely liquid, either heating or cooling. Besides, the whole electric box, the surface of it is the aluminum alloy. The purpose of it is just to release more heat. And also you can find at the surface there are lots of the lips. This also to help to release the heat. It will be 4 times higher than the thermal than the metal plate, which is the GMV5. And for the IPN cooler, you may have a worry that on the surface of it, if in a high humidity condition, we will be condensing water. And the condenser water, if it generates at the IPN, it will also very easy to make it to be damaged. And for this one, we already consider about it, and also we have the solution, which is to higher the temperature of this refrigerant to avoid the refrigerant lower than the dew point, which this will not generate the condensing water. Heat bypass anti-freeze pipe located at the bottom side of the outdoor heat exchanger, which means at the bottom side, this part is not the same as the upper side. And you can find that for the ventilation system, if the far away from the upper, the fan motor, which means the air volume also it will be poor, also indicates the heat transfer amount at this part is very poor. On the other hand, during defrost, and the ice will become water and flow down, and easier to accumulate it at the bottom, which is at this blue area. And when we go back to heating, and then the lower side always will become the coated, which means the accumulated water also will become ice easily, right? So in summary, for the heat transfer efficiency, it will be very poor, and also at the defrost it will deteriorate or worsen. So we just sacrifice the bottom part and make it to connect with the compressor. And also during the defrost, when we send the hot gas from the compressor to the outdoor heat exchanger to melt down the ice, and then the water, it will become water, and then also send out a partial just from the compressor discharge to the bottom side, which is here, and send it to here, and which is controlled by this gas bypass valve. So we can prevent the water to become ice at the bottom, right? And this we can higher the defrosting efficiency, which means we can higher the heating performance. And on the other hand, it can also achieve the gas bypass function because it just connected the compressor suction side and the discharge. For the heat recovery system, as the outdoor unit need to handle the combination of different indoor unit operating mode, which means the best refrigerant circulate amount also it should be different. So in the outdoor unit, we have this device, which is this one. We call it a refrigerant tank to adjust the circulate refrigerant amount, which is according to the pressure and the temperature. The system will judge whether it is the best refrigerant amount. If it is not, so we have the adjusting method, which is stored into this one, which is stored into here, or by the pressure we need to pump out the refrigerant out from there to adjust the circulated refrigerant amount. Here is the detailed control method. So if we detected the circulating refrigerant is not enough, we will conduct the high pressure from the compressor discharge, which is from here, to conduct it to here, and then to make this refrigerant out. Just pump it into the gas liquid separator to make it to join the circulated refrigerant. And if we detected there are too much refrigerant, and then also we can absorb the refrigerant, which to make it to be the liquid, and that the efficiency is the best, which it will connect the piping, which is to the liquid pipe, just like this, and also make it to absorb from into the refrigerant tank. It's okay. And for this one, we can adjust the refrigerant amount for the circulated refrigerant. Gas liquid separator located here. Here is the appearance. You have two pipes. From this sectional view, you can find that here is the inlet and here is the outlet. The function of this one is by gravity or centrifugal force will separate the liquid part, which is make the liquid part will accumulate it here, and only the gas which will flow up and from this tube get in it, and from here to get outside, which is into the compressor. And the function of it is just to prevent the compressor, the liquid hammer. And also you will find this one, a hole here, which actually it is this one. There are a filter at the surface. The purpose of this one is just make the oil to flow into this one to lubricate the compressor, not the liquid refrigerant. Oil separator located here, just between the compressor and the two four-way valve. Its function is just to separate the mixture of the oil and the high pressure and temperature gas from the compressor. And here is how it works. This is the appearance. There are two pipes, one for in, one for the out, and here is for the separated oil coming out. This is the centrifugal type, which is by the gravity. The mixture, which is the oil and the refrigerant, get from here, and the heavier oil will touch the cylinder and then just make it to go down and flow out, as the gas refrigerant will just get through this one and here, getting into the system. And just like this. And from the oil return for GMV6HR, there are two passes. The first is the major oil return. It is always on. However, in low temperature heating, at that time, as the outdoor ambient temperature is low, which will make the oil viscosity to be low, which means the flow is not that easy. And also at that time, the compressor also at high RPM, means require more oil for lubrication. So we just create another bypass, which is the assistant oil return, this one, to flow back to the compressor for lubrication. At that time, we can achieve to conduct more oil to flow back to compressor, and also the compressor at high frequency. Also, it require more oil to ensure the system reliability, especially in low temperature heating. Is the most important compressor. This one, it is the same from Hitachi, the same as GMV5. Also, it is scroll, but this has the EVI, which short for enhanced vapor injection, which is very helpful in low temperature heating. And here is how we inject the refrigerant in heating mode. Also, from here, it is the liquid and a partial refrigerant. We get through this EXV, and then at this subcooler, the refrigerant will become gas. And then we just inject this gas into the compressor. And also, you can find that there are two EXV control how much amount we need to inject into the compressor. And this one, the subcooler EXV, it is 480 steps. For this one, it is only 5 levels. Although it is the fully, it is 480 steps. With this combination, we can achieve 2,400 steps to precise control the injection amount. And for two EXV to control, we not only we can achieve the dedicated control just like this graph, but also we can lower the injection amount just like this. That's all for this part of the presentation. If you still have any other question, just feel free to contact me on my personal email address.